Assalamu alaikum wa rahmatullahi wa barakatuh. We will continue our examples on heat of formation. Okay, we started by the example if we have a substance that has heat content like hydrogen sulfide here, we have hydrogen sulfide that react with 4 moles of fluorine gas, it will produce 2 moles of hydrogen sulfide and 1 mole of sulfur fluoride. Okay, here we want to calculate the heat of content for the following reaction. Okay, we have standard heat of formation. We have the rule. We said that the rule of heat of formation delta H equal sum of heat of formation of product minus sum of heat formation of reactant. Okay, so we will take each compound by its coefficient in front of it, like this equation. We have 1 mole here, and here 4 mole, here 2 moles, and here 1 mole. Okay, we will take the product at first. So delta H equal 2 times delta H formation of hydrogen fluoride plus this one, and plus delta H of standard heat of formation of sulfur hexafluoride minus delta H of hydrogen sulfide 1 only, plus 4 of delta H of formation of fluorine gas. تمام. Okay, so we will take the values of standard heat of formation. 2 times minus 273 plus minus 1220. Okay, this minus negative 21 of hydrogen sulfide plus 4 times 0. We said that the standard heat of formation of any element equal 0. Okay, so the result will be negative 1745. Okay, after that we have another example. We have calculated the standard heat of formation of ammonia gas. Okay, we said before, standard heat of any type of reaction that depend on the result that have 1 mole of substance. Okay, here we have the equation that produce 2 moles of ammonia gas, not 1 mole. So we will take here heat of formation, not standard heat of formation. Okay, by the result at the end we will divide the result by the number of moles, divided the result by the number of moles. Okay, here we have nitrogen gas, 1 mole of nitrogen gas plus 3 moles of hydrogen gas that produce 2 moles of ammonia gas. Okay, we have delta H here for 2 moles of ammonia gas. The result delta H equal 2 times hydrogen formation of standard heat of formation of ammonia minus standard heat of formation of nitrogen plus 3 moles of, or 3 times delta H of formation of hydrogen gas. Okay, so we have negative 92.4 equal 2 times delta HF minus delta H for nitrogen, delta H of formation or standard heat of formation of nitrogen gas equals 0, plus also of hydrogen 3 times 0. So the product will be delta H F, delta H formation of ammonia gas, negative 92.4 divided 2 equal negative 46.2 kilojoule per mole. This is the change of heat of formation for formation of 1 mole of ammonia gas. Okay, we have here a note. If we have change delta H equal standard heat of combustion of 1 mole of substance completely combusted under the standard condition، يبقى دلتا اتش بتاعتي العادية تبقى اللي هي الهيت كونتنت بتاعي العادي. لو انا بتكلم عن 1 مول دي النوت اللي مركزة عليها دايما. لو انا بتكلم عن 1 مول يبقى انا بتكلم عن standard heat of composition of 1 mole of this substance. Okay, we will continue, or we will take another example. Here we want to calculate the change in the standard enthalpy of methane combustion, okay, according to the following reaction. We have methane CH4 plus 2 oxygen give 1 mole of carbon dioxide gas and 2 moles of water. By using the values of the standard heat of formation, we have here the standard heat of formation in the table. Okay, we have CH4. Okay, so delta H equals sum of heat formation of product minus sum of heat formation of reactant. So delta HC equal delta H formation of carbon dioxide plus 2 delta HF for water minus delta HF for methane plus delta HF for oxygen. Okay, so delta heat of combustion equal minus 393.5 plus 2 times negative 285.85 minus we said that standard heat or sum of heat of formation of the reactant all time take the sign negative. Okay, negative 74.6 plus 2.0 as we have here heat content of element oxygen equal 0. So delta H of combustion equal negative 965.2 minus 74.6 equal negative 890.6 kilojoule per mole. Okay, so we have here some rules to combine between heat of combustion and heat of formation. Okay, if we have standard heat of combustion of hydrogen gas here equal standard heat of formation of water, the same number of amount of heat, it's just a value. We can use some values for reaction to change it from combustion to formation just. So the standard heat of combustion of carbon here equals standard heat of formation of carbon dioxide. Okay, the same. We have opposite for formation and combustion. We have another example here. We have formula of butane. Butane, its formula C4H10. Okay, we want to calculate the standard heat of formation of butane gas. Okay, we have the here the standard heat of combustion just for it equal الرقم اللي عندي ده negative 2877 kilojoule per mole. Okay, suppose that we didn't have any standard heat for this examples. What we shall do, the first time we will replace. Okay, we have here 4 carbon atoms, we replace it by 4 moles of carbon dioxide. This is for combustion and here for this here for formation and here for combustion. 5 moles of hydrogen replaced by the same standard heat, but here for combustion and the other one in the other equation for the formation. Okay, here we have here of combustion 5 moles of water by replaced by the same amount of 5 moles of hydrogen gas. Okay, يبقى so we will add delta HF for carbon dioxide equal delta HC for carbon, so it will equal negative 394 kilojoule per mole. Delta H formation of water